Video is going to be all about symmetry and the identity matrix. So to start off with symmetry, it's important to know that only a square matrix can have any type of symmetry. Square matrix means it has the same amount of rows as it does columns. So the first type of symmetry is just called plain old symmetry, and it is equal to the transpose of a matrix. Now the transpose is the letter corresponding to the matrix, and you're going to see a capital T to the top right. I'm going to go over this in the next slide, but for now, just know that this means a transpose. So what a symmetric matrix looks like is this. You have your diagonal, which can be whatever you want, and the numbers right across are the exact same. So these numbers are the same, and so on. It looks like so. We have 1, 4, 6 on the diagonal. Those can be whatever, but here the 7 has to be the same as here. So 7 and 7, 3 and 3, and 5 and 5. Now, how do we take the transpose of a matrix? All we do is we take a row and we turn it into a column. So here we have row 1, and row 1 is going to become column 1. So 1, 3, 6, column 1, 1, 3, 6. Same for row 2 is 2, 1, 0, 2, 1, 0. That is the transpose. So if I were to ask you if this matrix here is symmetric or not, we would just take the transpose, and if it is the exact same as the original matrix, then it is symmetrical. If it is not, well, it's not symmetrical. So here we see that this matrix is not at all symmetric. Skew symmetry. So if a matrix is skew symmetric, it means that the transpose of the matrix is equal to the negative matrix. That means that we have a negative here and its corresponding number is positive. Here we have 45, and now we have negative 45. 4 and negative 4. Again, the diagonal can be whatever you want. So if I were to take the transpose of this, I take a row 1 and it becomes column 1. And you see that the 2 and the negative would just switch signs. And that is it. The last thing is the identity matrix. It is written as capital I, usually italicized, and if it's capital I2, that means it is the identity matrix for 2 by 2 matrix. This is what it looks like. So along the diagonal, it has 1s, and everywhere else, they're just 0s. So if I have a 3 by 3 matrix, I have 3 1s down the diagonal, and I have 0s everywhere else. So the identity matrix and even symmetry are going to become more and more useful as we go on in this playlist, but for now it's just important to know what they are.